So with all the new development on this advanced matrix controlling module, I decided that I would take this opportunity to create another video which will hopefully demonstrate what was missing in the last video, as well as explaining all the new features that have been implemented into this module to make it that much better. So I have a demo program. It's the one available from the website, and it's been loaded already to my MC3. I've set the input properties for sync detect on one of them, just to demonstrate that functionality. But you've got presets by name with feedback, which will route stuff to the outputs in terms of the virtual matrix view. You've also got snapshots. So there's nothing in that slot right now, but I can save something to it. So input 1 on both, and you'll notice that the sync detection followed the routing. So I can set that again. Press and hold, and we can save it to snapshot slot 1. And it saved it with the timestamp there. I'll explain that a bit later. But you can also import and export snapshot routings from the controller file system if you really wanted to. And that is useful if you need to transfer snapshot stuff across different systems. You don't need to manually set things up on every single system and then save to disk. But everything is controlled from this configuration file. I've added support for XML as well, so I can show an example of what that looks like. It's a bit more bulky than the JSON format, which is one of the reasons why I chose JSON as the top priority for the configuration file format. But it contains all the same information that the JSON one would. So for this particular file, this is the file that is currently loaded on the system. You have your matrix definitions array, and currently in this program I only have one matrix device, so there is only one matrix definition. At the very top you've got your identifier. For JSON configuration files I support comments, which get removed before the JSON is deserialized. This matrix identifier needs to match the identifier specified in the parameter for the device symbol, as well as the crosspoint routing symbol if you're using output control remapping. But for inputs and outputs you have your virtual and physical remapping, as well as the name for the input or output. The only difference is this control crosspoint ID for the output control remapping. And what this essentially does is if, for instance, you're controlling a DM switcher and you have your control signals tied off the DM endpoints, so the receivers, to control displays and things like that. If, for instance, output 1 and 2 got swapped, then you can't realistically use the same signals to control those same devices, because it now follows a different path for the control. So this remapping here will take care of all of that for you. It'll remap your control crosspoint over to a different equipment crosspoint based on this remapping, so that you don't have to change anything in your core logic, and that is pretty useful. And a big time saver, I think. So some of those instructions are described here. In terms of this file, based on the program, I do have that implemented. So if I was to connect to my MC3, we can verify the routings by using the root symstat command. So currently what you see routed here is the control ID of 1001, and that's routed to 1006. 1002 is routed to 1005. These are derived from the virtual output to physical output remapping. So virtual output 1 is remapped to physical output 6, which essentially means you're using the control ID off of virtual output 1, and you're connecting it to a new virtual output 6 at 1006. And the reason I did it this way is for simplicity, so you don't have to control Crosspoint to commit Crosspoint stuff for remapping here. You just edit your stuff here in this configuration, and the modules take care of all the remapping for the Crosspoint IDs for you. But what this means is your control Crosspoint for the virtual side of the logic for virtual output 1 needs to have the same ID for the equipment Crosspoint for the physical output of 1. So to quickly dive into here, just to show the IDs so I don't forget. So physical output 1, this will be tied to the control signals for the DM receiver off of output 1 off the device symbol itself. And then, so you've got your transmit and your receive on that end, and then you just add all your virtual control logic on this end, which will pass those signals through to physical output 6, in this case from virtual output 1. Snapshot's default name, you did notice that it didn't show this weird string in the name. This is actually a dynamic variable. Currently I only support datetime. It's the only dynamic variable that I could find would be useful in this case. But this is derived from the standard .NET datetime class for the now property. And the formatting of this datetime value is derived from the format string here, which would normally be passed to the toString method. So if you want to see more format strings as examples, just use msdnf as a reference for more details. And then you can choose whatever format you want, or no format at all, and essentially that would be the same as calling the toLong datestring format function. And this gets assigned to a snapshot whenever a snapshot is created in a slot that doesn't already contain snapshot information, and that is retained when you overwrite the snapshot data. So if you were to add a different routing to it, it wouldn't change the name. However, you can change the name later if you wanted to, through the module itself. The cache file is saved to this location. If this file doesn't exist, or the path itself doesn't exist, the module will take care of that for you, so you don't need to create this file with nothing in it, or this folder structure. And that saves time from you having to use your favorite FTP client like FileZilla to create this directory and then add this file with no information in it. It'll create that on the write operation, or if the no file exists, then it just won't read any data from it into memory. And then the last section is the routing presets. So these are the hard-coded versions of the snapshots essentially. So these are fixed in the file. They're recalled based on name to make the program more intuitive for what kind of presets you're calling and what they might do. And then of course you got your virtual input and virtual outputs. You can define one or multiple of those routings. Just like the snapshots, the reason why I went with the virtual numbers for the presets and the snapshots information is simply because if you change your virtual input or your virtual output remapping on the inputs or outputs section, if I use the physical indexes, that might mean that you would need to change all your presets and your snapshots would become basically invalid at that point. So I used the virtual stuff since that's subject not to change, and simply only the physical indexes will change most of the time. So that's the file. In terms of this stuff, I've also got the ability to route a virtual or physical input to all outputs, so you can see that here. For the snapshots, the cache files, I can demonstrate that functionality here as well. So I've already got the XML stuff loaded there, but this one's using the JSON. This was from a previous test that I did to make sure that the XML parsing worked properly. So let's just start with a clean slate here. If I delete this folder entirely, and now if I save this routing, which is basically input 1 to all the virtual outputs, we will save that to slot 1 and take note of the name. So if I save this, it's been written to disk. I have to refresh files in order to see that folder and the new file created. But if we open this up, you can see that name was saved to disk along with the slot 1 routing information. And this is a very minified version of JSON serialization just to keep disk size down, but if you wanted to, you could load your own snapshot cache files to disk based on your own manual edits. You could have it indented. The JSON, the Newtonsoft JSON library doesn't really care too much when it comes to however you want to format this information. But we saved that one, which had a snapshot routing of input 1 to all the outputs. So that's on disk right now. If I overwrite that snapshot slot 1 routing with an all 0 state, you can see that it recalls all 0. But the version of the snapshot routing on disk right now, if we read that back, you can see you get the feedback. And now if we call slot 1 for the snapshots, you've got that routing back that we saved from before, where input 1 gets routed to all the outputs. And of course, just like the presets, snapshots you have basically unlimited. It depends on how many snapshots you need and how much memory and stuff you're willing to sacrifice, because all this stuff is stored in memory. Same with the presets once it gets loaded from the configuration file, which gets loaded through this button. However, because in simple, this is a UMC, I've only defined 128 signals for everything here. So the names, if you need that for a list, for instance, you've only got 128 of those. So you'd have to build this module further, or I would need to build it more if you needed more than 128 user configurable named snapshots, and get feedback for those. Otherwise, you can save snapshots at slots 129 and above, but of course you wouldn't get the name feedback because there's only been 128 signals defined for that. And same thing with the partial snapshot information here. But it skipped 2. I just noticed that. So really there is 128, but that might have been from one of my edits. And then so in this module, this is the device module, which is responsible for controlling everything on a physical matrix in the system. Here's where you can recall a preset by the name. If you select the snapshot index, you can set a name to that and then choose to save it to overwrite the name for that snapshot index. So this is where you can change the names after they've been given a default name. So you can update your list. So the users can essentially create snapshots in whatever slot they want and change the names to whatever they want to describe what those snapshots do in their own systems. And you wouldn't need anyone to go into the configuration file to change stuff like presets. You can have these as fixed routing values and snapshots as user configurable ones. And then you can save, recall, write to disk, or read to disk. Oh, read or write to disk. And because snapshots save the routing for all the outputs, when you recall that, by default, it will route that full snapshot definition. Not in here, those are presets. Where is it? It will route that full snapshot definition to all the outputs. So if you wanted to bypass that and you only wanted to recall partial information from that full snapshot routing, you can define to enable the recall for outputs 1 and 2, and then out of that full snapshot routing information, it would only change outputs 1 and 2. So that is useful if you ever needed that functionality. If, say for instance, if you're using some of the outputs for fixed routing values, like routing cameras for instance, then you can leave those unchanged without not allowing the user to have their snapshot recall functionality. Every branch here is expandable up to 128 inputs or outputs. So you've got a maximum of, I would say, 128 by 128 in terms of the matrix I/O for as many matrix devices as you want. You'd of course just have to build that into your configuration file for each matrix definition. And to quickly explain the matrix module identifier, this is where this gets mapped to a physical matrix definition in this file. So the identifier needs to match what's in the configuration file in order for this module to fully initialize. If there's definitions in here that aren't from the program, so they don't reply back as being initialized back to the controller, then the controller can never fully initialize to tell all the matrix devices in the system that they're okay to proceed with their routing behavior. So that's something to keep in mind. For the simplicity of having each symbol completely isolated from having to tie inputs or outputs to one another, that's just one of the things to keep in mind about this hierarchy of symbols here. And then I've also got some comments that you guys can see if you're reading this demo program. So the C-cross stuff, this is to use for all your virtual logic. None of the physical stuff should be in here really, because all this is based on the virtual side of the logic in terms of this module. For these branches, basically, like I've already done, you'd most likely just be taking the signals off your crosspoints, tying them directly to the devices, and not programming any further functionality here, because this all exists on your virtual control side for all the commands that you're going to be sending across. These are just dummy commands for now. So if you opened up Debugger and post these signals, you could see which equipment crosspoint those signals get sent to. and this is the module here, which again needs to use an identifier that is mapped with the matrix that you're using for this endpoint control. And these just get tied over to a simple Crosspoint utility symbol that I created, where on the change of this analog, the control crosspoint with this ID gets routed as a one-to-one connection to the equipment crosspoint specified by this equipment ID. And so it'll disconnect to make sure that it maintains a one-to-one connection between these two IDs for control and equipment. You can, like in this example, take some control from the controller module. In this case, it didn't really matter whether I had the clear routing on the controller or the matrix device. The difference here is that if you pulse this one, it'll clear the routing on any matrix devices that it found in the program based on the definitions from the configuration file for the matrix devices that reported back to the controller as being initialized. So because there's only one, it would globally clear all the routing for just one matrix. So that could have been on this input instead of that output, and it would have done exactly the same thing. The only difference is that this input gets broadcast to all the different matrix devices. So if you only wanted this to be isolated to one matrix device, you should be using the matrix device symbol for that control. But in addition to the clear routing, aside from all the configuration stuff, the controller has the ability to globally call presets across any matrix device, save or recall snapshots, or read and or write snapshot cache files for every matrix device, and then route inputs to all outputs based on the virtual value or physical value. And the last thing is the license key here. So make sure if you're using this module for any project of yours, and not just to test this functionality for an hour, you should be using a proper license key to maintain that this module works for past that hour mark. And the reason why this is global too is because the cache files are per matrix device, which is why in the configuration file it's within this matrix definition that you can find the default name for the snapshots for this matrix and the cache file which is specific to this matrix. And then just like the device module, you also have error output feedback here. And the reason why I did this is because I could have allowed it so that this library always threw an exception whenever it encountered an invalid configuration file. But some people might not like that. So if you're not paying attention and you don't have this stuff on your UI to trigger a pop-up for when an installer or technician loads a new configuration files and tries to reload it, then you would never know that it is an invalid file that couldn't be parsed from the controller. But that is there in case you need that feedback, and I think that's better than throwing an exception. The only exception that gets thrown from my module is if you have more than one advanced matrix controller in your program. So there can only be one of these symbols per program, and my library checks for this, and if it finds another instance of a controller in this program, it will crash the program, and you'll see that a very distinct reason as to why in your error logs. But I think that covers most of it, and this is one module that I'm pretty excited to be using in a lot of my own projects as well. So I hope many of you guys are just as excited as I am to start using this to create some very powerful programs for matrix switching.